Hello, sir. Hello.
Hello.
Boleh minta menu attendance kah?
Apa dia?
Boleh minta menu attendance kah? Kami pakai phone.
Ya kah? Tu memang saya dah ya lah. Apa saya dah nak mulai eksperimen dah tu. Okey, telefon tu.
Ketengok aja nah.
Ya, nanti. You know this is a lab class, right? You should have your laptop ready actually for this. It's okay. Manual attendance will be done. Will be entertained after after the session lah. Okay. I don't want to
Okay,
disrupt.
sir. Thank you.
Yeah, I don't want to disrupt this flow just yet. Let those that can actually log in with the QR code do it first. For those unable to use the QR code, just leave your name in the comment. In the apa comment in the chat. Yeah, I think in the chat. For my record to do manual attendance later. Okay.
Can I have manual attendance?
Hey, you didn't hear what I said just now?
Oh, saya lambat masuk, sir.
Okay. So just open the chat. Okay. For attendance, leave your name. Okay. Okay, you guys can open the chat. Made small announcement there. Oh, cepat Dorian. Yeah, maybe apa ni? Sorry, sir, line let's connect the top Wi-Fi slow. Upgrade your Wi-Fi. What Wi-Fi? What line are you using at home? Oh, are you at home? Kamu tengah pergi sekarang
You
tengah pergi shop.
mobile.
What? You mobile? Apa pakai data ya? Pakai data?
Oh, pakai data.
You data tengah jalan, tengah sono pergi shopping ni. Oh, ada kelas dah buka sekejap.
Sudah. Dalam bilik.
Dia kena minta bukti semua ni, buka gambar, buka video, kamera semua kan. It's like the classes done overseas. Kalau kita macam meeting, even the meeting that we are having here in our faculty, they want everybody to for a while open your camera. Okay, we want to take a selfie. Sebenarnya nak tengok kan siapa sebenarnya kat office, siapa tak ada kat office tadi tu. It's okay, kita I'll let the QR code on first. So Assalamualaikum warahmatullahi wabarakatuh. Tamit orang Jepun kan. Okay, so let's start again. Assalamualaikum warahmatullahi wabarakatuh and very good kita panggil evening je lah. Evening, afternoon. Okay. Sekejap, mana pergi belakang ni? Lupa dah saya. This one. Yeah. And a very good evening, afternoon, evening. Yeah, depending on your mood. Yeah. To all class members. And this one is third year class PKE. Okay, welcome to KNR3492 Electrical Lab 2. Electrical Lab 1. Electrical Lab 1 for semester 2. For semester 2 2020-2021. So I will be the second lecturer in charge for this lab after IR Hazrul. And I was kind of surprised that he told me that he already finished last 2 weeks. His lab's last 2 weeks, and that was week 3, right? So I was not ready last week because I thought at the very least he will take around 3 weeks. 3 weeks because referring to our course plan. Okay, referring to our course plan, there are more labs on because they ambil electrical machine. So the division in in handling this lab is Dr. Hazrul will take electrical machine, experiments on electrical machine. So then I will be in charge of experiments on transformers, on transformer, and then finally Associate Professor Dr. Ahmed will take over for the last part, which is on the power system control. And that was the deal earlier in the semester. Although it is true that lab 2 is a measurement of resistance and copper loss, right? That one is lab 2 after the briefing safety rules in lab 1. And then electrical machine again, experiment 3, magnetization, characteristic of the DC generator. And then comes transformer, okay, which is what we are going to do today. Okay, transformer single phase. Okay, transformer single phase. And then transformer load operation characteristics. And then after that, it should be followed by another 2 sessions of electrical machine. Okay, electrical machine starter with stator resistance, and then a star delta starter. So, somebody from the class, anybody, let me know. Have you done transformer? No, the electrical machine star delta starter with Dr. Hazrul?
No, sir.
No. Itulah. And then I was also surprised to check that there's no, I think there was no attendance taken before. Ada ke attendance taken before? With Dr. Hazrul? Hello?
Macam tak ada je, sir.
Yeah.
Kita orang attend, kita orang ada. Jangan risau.
Yeah, I believe you guys. I believe you guys. Not because I don't believe you guys. It's just that the attendance here, class attendance. If I open here, see, mine is the first one here. Yeah, mine is the
Macam-
first. Today is the first time we're taking attendance.
Dia macam tok sir.
Yeah, entertain
Kelak
me.
Dr. Hazrul manually letak nama kami orang. Even in his class yang lain pun yang macam ya juga.
Yeah.
Hmm.
Why? We
I don't
are
know.
moving to digital age now, and why is he? Maybe I should ask him later. Because everything is done online now, and this is basic on the very basic level lah, attendance. Because before all this COVID thing, we already use this one, right? Use QR code previously. So yeah, it will look a bit bad on the course coordinator later kalau attendance tak cukup. So yeah, there's that. And then he asked you guys to do two experiments, right?
Yes, sir.
Yeah, I tried to open the experiment one. Anybody having problem with experiment one? The website tu ada problem tak? Ke tak ada?
Sir.
No problem, really.
No, so
I was not able to make it to work. I cannot drag the wire cable there. Tak boleh tarik.
laptop saya lah ya. Kena.
Bukan laptop saya lah. I already tried with my PC, my laptop at home, PC here. I cannot do anything. But when I open laptop, experiment number 2 was okay. So yeah, I don't know. Hopefully with just so you know that I hope Dr. Hazrul has already told you guys about this, that even with this lab session going on, you will not get your grades for the end at the end of the semester. Tahu kan? Tahu ke tak tahu ni?
Sorry? Come again?
You will not get your grades for this lab in the end of the semester. It will carry over to next semester.
Yeah.
Tahu kan?
Tahu.
Okay, so hopefully that was what Mr. Hazrul has in mind when he planned his classes, because apparently he has another two experiments. Starter with stator resistance, and then star and delta starter. That one is should be done by him. So tak apa. I don't know what he's planning for his class, but so minggu lepas tu masuk saya punya lah. Minggu lepas minggu ni pun kira lah saya punya. Now we have around 87 students, so minta dua orang yang dua orang yang minta manual attendance. So the others. Dan kita ada 89 orang je in the class. No, right? There should be more, right? And so it's been 12 minutes now, about after 2. Okay, so past 2 o'clock. So I think we can start. Boleh?
Boleh.
Okay, yeah. Okay, so starting today, so from my session onwards, we are going to look at transformer. So hopefully a lot of you knows what a transformer is, right? And then the experiment for today is very simple. So how I'm going to handle this class is a bit different from Dr. Hazrul. He was using that website kan, yang website apa tu? Benda binatang tu, website. Yang sometimes you do the some kind of a simulation, right, online, to do this and that connection, and then the graph comes out, right? The graphs come out, and then yeah, it's good in a way, but it's not real experiments lah. Yeah, there's no true calculations at the back of the one. It's just the visual simulation of experiments. So I tried to find something similar, but it's macam tak ada. So I decided to go through the experiments with the transformer, the sessions experiments lah, the experiments with transformer using Matlab. Okay, so first can you guys let me know, have you guys installed Matlab yet?
Yes.
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 Matlab, please don't tell me tak install lagi. We are Unimas is providing free copies now. Unimas is providing free copies of Matlab to all warga Unimas. So you can actually install Unimas version, Matlab version lah. The latest Matlab version through Unimas. Ambil daripada Unimas. So I have some couple of beberapa FYP students already did that. I don't know.
Nak ambil kopi tu yang Unimas provide.
Ya, tak boleh download. Apa nama? Macam mana download? Saya pun dah tak tahu. Saya tak tahu macam mana download. Dia tak bagi tahu ke macam mana nak download? Tak ada.
Dia biasa
Boleh
download.
tak?
Download dekat luar website je.
Saya pun cik tahu.
Jangan pirate pula. Don't pirate this. This one is a full version of Matlab, sponsored by Unimas. So nanti saya tanya macam mana? Because from our side here, kita download daripada apa tu, FTP server something. FTP server. Nanti saya tanya lah macam mana saya punya FYP student download. I thought everybody knows already. Dia tak beritahu ke macam mana nak download? Tak ada announcement ke macam mana nak download Matlab from Unimas? Tak ada? Using campus license? Tak ada?
Mesti ada rasanya info.
Ada kan? Saya rasa ada lah. Macam mana Matlab Unimas? Campus license. Apa nama download lah? Macam mana? Saya pun tak tahu nak cari macam mana.
Unimas portal, sir.
Unimas portal? Saya pun tak nak masuk Unimas portal. Bagaimana portal lah?
Ya.
Portal.unimas.my. Saya dah lama tak pergi portal lah, because when we move over to office, saya dah tak pergi dah portal ni. Okay, so macam tahu je cara download tu kan. So that's good. So this is a good preparation for you to download Matlab from now. And then tak ada lah. Because you will be using some of you will be using Matlab for your FYP also, which will come next semester, right? Next semester this year. Okay, so it's good for you to start to familiarize yourself with Matlab. Tak boleh ni what? Why? Portal Unimas.
Server down.
Ya ke?
Ya.
Ke sebab saya pakai alamat lain? Inilah ini. Ini korang punya bukan macam ni kan? Kan macam ni juga? Student punya? Sama? Okay, so how? Macam mana download dia? Support, academic, research, academic. Macam ni ya? Research ke?
Pergi Maths Work, sir.
College, alumni, supporting study, course registration, online data. Online, bukan, ini bukan kan? Mana nak download support dah?
Pergi dekat
Training
email.
bukan. Communication.
Email.
Application. Financial management, personal matters. Tapi kat sini lah sama kan? Request, booking, library. So, yalah, try to find a way. Nanti saya tanya lah. I forgot how we download because the way you download it, I downloaded lecture tak sama. I never went to this portal. So, I don't know. Okay, so cari cara macam mana nak install Matlab, okay, from Unimas. Okay, so that is your first task lah. Okay, that is your first task for the lab. Sebelum kalau boleh install Matlab. Okay, and then jangan skip anything dalam Matlab waktu the installation tu. During the installation dia akan minta you pilih apa? Dia punya toolbox semua, install saja semua. Okay, just install everything, don't skip anything, so that you can use it as intended lah. Okay, so before we move further, how about we ini kita tengok video sekejap. Nah, okay, just to refresh the memories back on Transformers. Boleh tak?
Boleh.
Yeah, 5 minutes video. So, macam mana? Boleh lah, try lah. Kalau tak ada bunyi ke apa, beritahu saya.
Transformers are capable of receiving AC
Ada bunyi?
power at one voltage and delivering it at another voltage. In this way, they help achieve
Ada bunyi kan?
efficiency while transferring
Ada.
power over longer
Tapi
distances.
tak kuat lah. Maybe saya kena mute.
In this video, we will go through the working and construction of a three
Saya tak dengar terus.
electromotive torque across it.
Now?
Okay.
Such a fluctuating magnetic field can easily be produced by a coil and an alternating EMF system.
Kalau tak apa dengar pun baca dia punya subtitle lah bawah tu .
A current carrying conductor produces a magnetic field around it. The magnetic field produced by a coil will be as shown in the figure. With the fluctuating nature of the alternating current, the magnetic field associated with the coil will also fluctuate. This magnetic flux can be effectively linked to a secondary winding with the help of a core made up of ferromagnetic material.
Okay, the arrow shows the the different flows of current, the changing flows of current. Yeah, due to the use of alternating current, so current will move forward and backwards.
Since the turns are arranged in a series, the net EMF induced across the winding will be the sum of the individual EMFs induced in each turn.
Now you are starting to see familiar equations, right?
Magnetic flux is passing through the primary and secondary coils. The EMF per turn for both the primary and secondary coils will be the same. The EMF per turn for the primary coil is related to the applied input voltage as shown. As a result, the induced EMF at the secondary coil is expressed as follows. This simply means that with fewer turns in the secondary than in primary, one can lower the voltage. For the reverse case, one can increase the voltage. But since energy is conserved, the primary and secondary currents have to obey the following relationship. Three-phase transformers use three such single...
Okay, so yeah. So three phase tu kita tinggalkan kemudian, but that is the basis lah. Okay, that is the basis for transformer. So I hope that is that serves as a very good, what do you call that, refresher. Okay, refresh of your memory for those of you that already forgotten what a transformer is. So yeah, so let's look at the experiments themselves first. Okay, so as for today, we are going to start with experiment 3, which is Doktor, semua ada tak lab manual ni? The lab manual for this class ada? This one. Has Dr. Azrul shared this one? Lab 3, lab manual? Hello?
Tak ada rasa tu.
Tak ada? Okay, so tak apa, so I will put this one online lah, on our elite later. Okay, so for if you are going to do this face to face lah, if you are going to the lab later, so this is the apa nama? This is the experiments that you will be doing first. So experiment 3, single phase transformer. So this is the layout lah. This is the layout of transformer that you are going to be using in the lab. Okay, where this is the primary apa nama tu? Coil. Yang ini depan ni. Windings, primary windings. Okay, IU1 to IU2 is the primary windings. And this on the right hand side are the secondary windings. Okay, so depending on where you cut, hello? Hello?
Yeah.
Yeah, can you guys hear me now? So, sorry, saya hilang sekejap. I don't know what happened with Webex. Kalau saya yang jadi host memang jadi macam ni ya. Dia ada masa saya hilang. Saya yang hilang kan. So if suddenly I got stuck there, don't leave the meeting yet. I will try to come back. Okay, so coming back to this. Okay, coming back to this one. So everybody can see the PDF, right?
Yes, sir.
Yeah, okay. So depending on where you cut the secondary winding study, so you can have multiple here. This transformer in the lab allows us to have multiple settings of windings for this transformer, where you have this transformer primary is fixed IU1, IU2, but secondary you can either have each and every one of this, means it's between 2U1 to 2U3 or 2U1 to 2U4, okay, or 2U1 to 2U2, and it will become different windings, okay, different windings because it represents the different numbers of n, okay, number of windings study. So as you can see, the smaller the windings for the second one, the smaller the output voltage becomes, right? Okay, because it represents this is in at the very base of it. This is a step down transformer. Okay, step down transformer where this is the primary voltage of 230 volts. It goes down to can go down to 53 volts if you take the lowest number of secondary windings in 2U1 and 2U3. So, so before we move there, so I would like to talk a bit about transformers. So before we look at this, ada berapa orang rasanya yang dah install Matlab? Ada yang dah install Matlab tak? Siapa? Among you that have installed Matlab in their laptop ke PC ke? Ada kah? Ke tak ada? Ha? Ada?
Yes.
Ada? Okay, because if you have installed Matlab, then kita boleh buat eksperimen ni sama-sama. So that's why your first task, maybe it was my fault too, not to I didn't put it on online to ask all of you to install Matlab. Any version tak kisahlah, any version as long as it's newer, but lebih baru daripada 2016A. Yeah, later than 2016A will be okay. So that will be a task for next time lah. So your first task tadi macam saya cakap is to install Matlab. Okay, so transformer, okay, do what the name implies, which is they transform voltages. Okay, they transform voltages from from lower to higher and higher to lower. Okay, itu selalunya lah. Okay, what we use transformers for. Okay, so okay, for example, the simple one is you can look at your phone charger. Okay, yang phone charger tu, okay, where you put it on the connect it to the wall, right? To the outlet at the wall there, the 230 volts, and then it goes to give your phone berapa volts? Dalam 5 volt kan? Selalunya for USB. Okay, charging 5 volt. So depending on for current situation, for current development, so we have ada yang pergi announce super fast charging, everything. That one has to do with their punya how much power it can deliver per cycle. So it depends on the how much current it let go through into the phone without damaging it. Okay, so as of right now, okay, so that is the simplest example of everyday transformer that we all have at home right now. Then and there are a lot more of other tools out there, that other equipments out there that is not going to utilize the full 240 volts from the outlet, like your laptops, right? Your laptops selalunya dia pakai dalam 19 volts. So that's why when you charge your laptop, there is the power brick in the middle, right? That power brick is actually a transformer. It steps down the voltage. Step down the voltage so that it can charge or it can powers your laptop to the 19 volts that it needs. Okay, from the 240 volts on the socket. And then even TVs nowadays, they are also using low voltage, not 240 volt from the socket. So if you're buying flat screen TVs, flat screen monitors, okay, they come with that power brick. That power brick is also that is what we consider as a transformer. So power is sent. So the point of using transformer is actually to minimize power loss. To minimize power loss, because usually power in real life, powers are delivered over a very long distance, right? Powers are delivered a very long distance. You don't have this empangan bakun at the back of your house, right? You don't have this, contohnya kalau nuklear kah, okay, nuclear power plant, you don't have those things right next to your house where you want to use it, right? Usually we obtain, okay, we generate power, we generate electricity far away in the forest, far away in the wilderness, out there before we use it at our home. So in this long distance, okay, transferring this energy, transmitting, in the terms, the correct terms is transmitting this electrical energy, okay, will incur a very huge losses if there is no transformer. Okay, losses when we talk about electricity is in the form of apa tu kita panggil P equal to apa? I square R kan? Okay, P equal to I square R. So you just imagine if the when the power is equal to P equal to IV kan? So when power is generated, so that voltage and current are multiplied to obtain the value of power, right? So imagine from Bakun sana, they transfer power directly to your house at 240 volts. There's no transformer. Okay, so can you imagine berapa kilowatt produced by Bakun? Megawatt, okay? Kilo megawatt can produce at Bakun, divide by 240 volts. Imagine the amount of current that is involved there. Because like in the like shown in the video today, okay, energy is conserved, energy is conserved. This the follows, okay, even though the voltage can be step up and step down, current needs to follow, okay, if the follow depending on the formula P equal to IV. When you increase the amount of the voltage value, the current will go lower. Okay, if you decrease the amount of voltage, then the current will go higher. Okay, so following the rule of power law study, P equal to IV, we want the smallest current possible, okay, during the transmission process, right? During transmission process. So transformers allow this to happen, okay, where from the Bakun they up, okay, they're up converted, okay, the step it up to several thousands volts, okay, so that the current will remain low, and then it distributes it long distance with the help of transformers to step it down back later where we want to use it. Okay, so power is sent long distance here at high voltages because less current is required for a given amount of power, and this means less line loss, okay, as was discussed previously. But with high voltage, okay, pose a greater hazard, so that transformer are employed to produce lower voltage at a user location. So this is dulu lah waktu saya balik daripada when I came back from Japan saya banyak bawa barang-barang dari Jepun, barang-barang ni, and then this electrical appliance from Japan, they use 100 volt, okay, 110 volts compared to what we use here in Malaysia, 240 volts. So I need a step down. Okay, I need a step down, a portable like this one. Okay, I used to have a lot of this lah, okay, at home to use the appliances that I brought back from Japan. Nowadays, no more lah. Nowadays, it's not very common anymore because there are a lot of manufacturers are making their appliances to be universal. Okay. Sorry, that's my mom calling. Okay, so that's what I call it. So here is the theoretically how it works from the power plant. Okay, produce around 12 kilovolt, and using the transformer, it step it up to 400 kilovolts before it goes down to the substation. Used through a transformer again, step down to a lower voltage, kilovolt, and then before it reach residential buildings, it step down again to the amount of voltage needed, like here 240, and then dekat kilang dalam 400 berapa? 412 in the factories, if I'm not mistaken. So the type of transformer that we are considering here is based on Faraday's law. Okay, Faraday's law of induction, and is very similar in construction to the apparatus Faraday used to demonstrate magnetic fields. Okay, and it could cause currents. Okay, the two coils are called primary and secondary coils. Okay, and then not only does the iron core trap the magnetic field created by the primary, its magnetization increases the field strength. Okay, since the input voltage is AC, okay, a time varying magnetic flux is sent to secondary inducing AC output voltage. And then this one is what you need to keep in mind, that transformers is only used with AC, okay, with AC, okay, tak ada apa nama, we don't use transformer with DC. So that's why in such applications that requires high voltage of DC, like in electric car contohnya, atau hybrid car, okay, instead of using transformer, which is not possible, okay, it use DC-DC converter, okay, DC-DC converter to convert from a lower voltage to the higher voltage. Okay, so it's a different, okay, different appliances, different components. Okay, where with AC we use transformer to step up, step down, but with DC we use DC-DC converter. Okay. So like shown in the videos just now, this is the basis. This is the basis of the transformer, and here is the symbol for transformer. Also used. This is basically what I call that. General. Okay, a general symbol, a standard. Okay, you see like this. This is where this represents the coil. This represents the one here is connection, positive and negative. Here. Okay, yang voltage in this one current flow here, and then this represents the windings. Okay, and this one represents the core. Okay, that's why this is the symbol for transformer. Okay, so like this one usually kita label sebelah kiri lah, sebelah kiri as primary, sebelah kanan as secondary. And then from the video just now we can also see this one. Okay, for the simple transformer here shown here, V secondary, secondary voltage, okay, can be calculated using this formula, Vs equal to minus Ns delta V over delta T. And then because this is on the same core, okay, self-induced, kita panggil self-induced inductance, self-induced apa namanya itu, flux, sini self-induced EMF kita panggil. So where this changes of flux is constant through primary and secondary, so that's why they cancel over. Okay, they cancel each other. Okay, so because as you can see, V primary is also given by minus N primary, the same change of flux. So they cancel each other. Using these two formulas, we have Vs over Vp equal to Ns over Np, where S is secondary, P is primary. Okay, so this is known as a transformer equation, and it simply states that the ratio of the secondary to primary voltage in transformer equals the ratio of the number of loops in the coils, or the number of windings in the coils lah, primary and secondary. Okay, so the output voltage of a transformer can be less than or greater than or equal to the input voltage depending on the ratio of the number of loops in the coils. Okay, so some transformers even provide a variable output by allowing connection to be made at different points, such as this one. This is the same. This is one unit of transformer, but depending because this transformer allow for a different point of connection to giving different number of NS, okay, number of secondary coils, you can extract a different amount of voltage, different value of voltage, okay, from a single transformer. Okay, so as its name, a step-up transformer is one that increase, okay, step up the voltage, okay, and then step-down transformer can do the opposite, okay, decrease the voltage. Okay, it's just that always remember that it is never that simple, okay, because power and energy is at play here. So it's not always a good thing to do, okay, macam tadi kan, we go here at the, okay, here contohnya, here, as you can see from the power plant, 12 kilovolt, okay, in order to decrease the amount of current, it increase it to 400 kV. Okay, and then some genius are thinking, okay, maybe we can save cost by, okay, we don't need to use two transformer here, just use one. We step down directly from 400 kV to 240 V. Okay, that will cause a lot of problem. Okay, that is very dangerous. So that's why in the middle here, usually there are 2 or 3 transformers, substation or transformers before it reach your home. Okay, it's mostly for safety reasons. Okay, we cannot just step down from a very high voltage to a very low voltage in one go. Theoretically, yes, it is possible, but it's not very safe. Okay, it's usually not safe. Okay, so the equation that going through here that is taking place here is the equation of power, where even though you step up, you step down the voltage, okay, it's the amount of energy, okay, the value of power remains the same. Okay, if we ignore, if we tolak losses lah, if we put the losses, usually right now the efficiency is around can go up 99% or over right now, depending on the technology that we have right now. We can reach this very high efficiency of operation between from the power generation to the end user. Usually it's not this high because there are a lot of other variables, but we consider the losses at less than 1%. So the equation that is taking place is this one: power or energy, the amount of energy at the primary is equal to the power contained at the secondary winding. So IP VP equal to IS VS. So if for a step down transformer, voltage goes down, secondary current will be greater than the primary current. Okay, for step up transformer, because secondary voltage will be higher than the primary voltage, so secondary current will be lower than primary current. That's how it goes. Okay, mathematics. Okay, so combining these two, okay, combining these terms, okay, we have this VS VP equal to IP IS. Okay, and then combining it with this, so we find that IS over IP is equal to NP over IS. Okay, different. Okay, dia terbalik sajalah. Okay, so secondary over primary for current equal to primary over secondary for the windings. Okay, so this is a very simple example. So tak apa. Let's look at the experiments now, kalau boleh. Okay, this is the kind of exercise experiments that I am planning to do with you guys actually for the lab. So let's go and share another one, shall we? Screen lah. Okay, so screen. So saya minimize this one. I will also, okay. So for the general transformer action lah. Kita bukan panggil yang bukan kartun tu Okay, the workings of a transformer in for residential use. Okay, there is an example. Kalau in Matlab you can find an example, Okay, you can find an example. Okay, kalau example that one is embedded in Matlab, you can just call it by the power transformer over there. Okay, ini ada example lah for power transformer and press enter. It will open this example. Nampak tak? Nampak tak? Okay, so the Matlab will open this example to show you the working of a transformer for residential use contohnya. So here you can see that, okay, so like I said just now, like I said just now, theoretically we can do in one go, okay, using one transformer, 144 volt, 14,400 volts, okay, 14.4K, 14.4K volts, 60 hertz, and then through one transformer down to 120 volts. This is a system. Kalau kita dekat Malaysia, kita pakai sinilah. Winding from here to here. Kita ambil the whole thing, 240 volts here. Okay, but for this one, okay, they are divided into two because apparently the housing here using 120 volts. So two nodes here taken at a different point. Here provide 120 volts and here provide another 120 volt, 24 volts. 120 volts, sorry. So this is just an example provided free by Matlab. Kalau kamu ada Matlab, boleh try, tekan. Look at that. So this, all this you can atur. Okay, you can atur directly. And this one, hopefully you remember this one, peak amplitude. Okay, peak amplitude is 1440 darab square root 2 because this one is peak value is ini darab dengan RMS. Okay, bagi darab dengan RMS dia, so untuk dapat peak value. So if you just want to put it value voltage sahaja, you don't want to put square root 2 here, there is a library sini kita panggil kita ada library browser. Dekat library browser tu kita ada RMS this one just now, sorry, kita ada where is it, sorry, yeah, susah cari RMS. Okay, leceh cari RMS. Okay, tak apalah, saya ada sediakan nanti. I have a video that I would like you to refer lah. Okay, so this is just example. So this is a working simulation. This is a working simulation where it gives you input current here. Okay, it gives you an input current here, but you can actually add one more if you like. Okay, input current. Okay, sini kita tak ada ni kan, output current tak ada check sini kan. Okay, there is no output current here. You can add on your own. Okay, contohnya kat sini kah? Okay, nak letak kat situ. Okay, so you delete this connection. Okay, masuk sini, and then add new one. Okay, so now you can measure output current. Here will be output. Okay, that's why I like to use Matlab and Simulink. So because you can theoretically do anything here. Okay, depending on your needs. Okay, like this one is output voltage. Okay, this one it doesn't measure input voltage because yeah, it's already here. Okay, this one kita I out lah, ini I out. Okay, so using this simulation you can just press run. Okay, so saya buka tadi kan, mana dia punya ni, this one. So as you can see, here is the input current. Okay, here is the output voltage. Okay, and then here is the output current. Okay, ini lagi. Okay, here. Okay, from here you can actually compare. As you can see, this is a step, apa tadi? Step up ke step down nih? Anybody want to answer? Step up or step down? Transformer?
Step down.
Okay, good. So step down transformer, following the equation tadi, so sepatutnya which one is bigger? Input current or output current?
Output.
Yes, sepatutnya output current, right? So it is shown here that the output current is bigger. Okay, is bigger than the input current. Okay, because the voltage is bawa sini. Kita turunkan voltage dia ke 120 volts, but due to this you need to have an appliance that can handle up to 20 kilowatt. Okay, because the step down is very extreme, 14.4 kilovolts to 120 volts saja. So that's why on the input side kita ada dalam berapa ni, 6.7 volt, 7 ampere, and this one is reaching 400 already. Okay, 400 ampere. Okay, normal appliances cannot handle this much current. Okay, 400 ampere is quite a lot. Okay, 400 ampere is quite a lot, so that's why it is dangerous actually to go directly down from this high to this low in one go. Okay, so this is the type of experiments that we can do in Simulink. Okay, so kan kalau buat eksperimen tak payah buat graf sendiri, ambil screenshot kan. Okay, so I'm planning to use this. Okay, so to ensure this, betul tak output voltage dia sini sepatutnya kalau kita ambil in the middle here, sepatutnya output voltage dia before we move on, just want to ensure that ini adalah 120. Let's see, is it really 120? Ini apa ni? Output voltage. Okay, the output voltage here is around berapa ni? Peak dia sini. Okay, peak dia situ, so dia lalu this, dia dalam berapa ni? Berapa banyak ni? For this, using Matlab, you can do this, you can zoom. Okay, so around 100 ini, kalau kita bagikan square root 2 dapat berapa ini lebih kurang? Kalau 166 bagi dengan square root 2 dapat berapa?
117.
117, so around that one lah, around that value lah. Okay, around this value. Ini bukan bacaan lah, ini dia tulis sendiri je, just to make it simple. Okay, ini bukan bacaan. Bacaan yang sebenarnya semuanya dekat ni, meter ni. Okay, don't mistaken this for reading. Okay, ini just label saja. So that is example lah. The example how line transform linear, where this transformer dia ada two windings where you can set lah. You can set the parameters here, and that will be your task. So what I want you to do, I will close this one. I will close this. Okay, I will close this. And what I want you to do is go to sekarang screen saya kan, Okay, look at the experiment. Look at this video on YouTube. Okay, nanti saya akan share this video lah. Okay, because this one shows a simple experiments lah with transformer that you can do. So ini ada dalam ini lama nih, tempat you can learn lah. You can learn from this video on how to do a simple transformer experiments on Matlab. So from that video, I made this one. Okay, I made this one. Okay, this circuit yang ada this is a simple linear transformer lah. Okay, this is a simple linear transformer with two windings. Okay, one primary winding and one secondary windings. Okay, so because this one is a linear transformer, there's a difference, because if you search here for library, dia sini ada banyak library, a lot of things that kalau kadang-kadang you don't know where to find, you just look at it here. If you put transformer, okay, we give you, okay, ada ni ideal transformer, okay, and then 3 winding transformer. Okay, there's a lot of other transformers here. There are even transformer yang you boleh atur sendiri sini, primary winding and secondary winding, where you set the number of windings. Okay, but for the sake of these simple experiments, okay, simple experiment, we are not going to set the winding. Yang winding tu, I want you to use the formula to calculate. Okay, so right now we have this simple circuit to macam saya cakap tadi kan, like this one, peak amplitude saya letak sini 400 volts, tapi saya tak darab dengan square root 2 because saya cuma I want the peak voltage and then the true voltage, the RMS current and RMS voltage is going through this RMS block. Through this RMS block. This one. So here is the RMS value. Here is just peak value. Peak value and RMS value. I hope you remember the difference. Okay, what they means and then what they do, and then which one is the effective value, which one is not. Okay. So if you recall correctly, then you will know that the peak value is not the effective value. Usually what we look for is the RMS value, which is displayed here lah. Okay, but here is something that there is no need for you to look too much into display, because ini just this only shows real time display saja of the value. And in the experiments, what you need to do is set this, control these settings. Okay, control these settings to have sini dia direct terus saja. Dia tak kata berapa winding, berapa kiraan, berapa winding sana, tak ada. Okay, sini power dia, nominal power dia saya letak as 3000 VA, means there is not much power lah in here, just 3 kilowatts saja. And then voltage of this one is saya letak 400 okay, 400 volts. So because this one is 400, so here must be also be 400. Okay, the values, what these values inside here means is this one. Okay, in units here you can change either SI or PU, but for these experiments just use PU. Okay, pakai PU, jangan pakai SI, because with SI nanti ini, this one will not matter. Okay, this one will not matter in the experiments, which is a bit pointless lah. So use PU. Okay, use PU here. I want, okay, input voltage dia dalam 400. Okay, windings dia, second one is around 240. Okay, and then you calculate, okay, from the amount of current nanti and voltage, you calculate the number of windings using the formula. Boleh kan? Boleh tak? Ke tak boleh ni? Hello? Ada satu orang ni.
Boleh sir, boleh.
Boleh kan? Senang kan? Senang kan?
Tak ingat formula rasa.
Allah Akbar. Tengok baliklah nota. Takkan rumus untuk formula apa, transformer formula pun tak ingat. Melampau betul. Okay. Cari sini. Okay, so refer to that video just now. Okay, I will later give you the amount of power. Okay. Okay, so nanti saya bagi dalam kita akan buat graf lah. Kita buat graf. So you will see dia punya tu dia punya number of windings tu akan tukar. Okay. There are a lot of things that can be done here, like this one. This one is this is just a branch, branch connecting these two. It's not a load. Okay, later on you can actually this one can be considered as no load lah. Okay, you can RLC there, RLC. Okay, letak so. Okay, you can actually put it a load there instead of that branch. Okay, you letak sini load. Okay, so okay, so as you can see, these loads, okay, can be resistance saja, or with inductance, or inductance saja. So depends. Okay, this one you can actually ini load je lah. Okay, ini you can set the value later. Okay, you can set the value of this. Kalau tak, if there is no inductance, letak kosong. Okay, letak kosong, then dia akan become kosong lah. Like this one tadi, you can actually change for pure resistance saja. For pure resistance punya load per branch, there you will see. Okay, this is just an example lah. Cuba let's run this one time. Boleh? Okay, so voltage tadi 400. This is my setting. Okay, so in the primary saya letak power dia dalam 3000. Okay, 3000 watt atau 3000 VA here. So the winding in the 400 volts, and then output dia 240 volts. Yang lain jangan kacau Okay, because if you tengok kalau you tekan ni, this one, dia jadi macam tu. Okay, so we don't want that. So running this experiment, what we want to see here is this one, difference of primary current, secondary current, and then primary voltage, secondary voltage. Kalau tak pandai buat ni, belajar. That's your task. Okay? Boleh tak ni?
Okay, sir.
Boleh, seorang je jawab boleh. Jadi jangan kamu seorang je buat, nanti orang lain menumpang sekaki. Okay, so you have your groups, right?
Yes.
So yeah, at least one group tengoklah macam mana. So we open this. Okay? And see how it runs. This is what happened lah. Okay, and the experiment is only for 0.5 seconds saja. Saya letak sebab tu bawah ni 0.5. Sini. Okay, T dia 0.5 second. Kalau, because if I increase it more, then tak nampak. Okay, this one depends on your computer or laptop. Kalau computer and laptop you laju, this one will finish in a blink of an eye. Kejap dia habis dah. Okay, kalau slow, then nampak macam ni kan. Okay, so here is the difference. Okay, like, so this one just now, my setup is step up ke step down transformer. Hello? Hello? Mana orang ni?
Down.
Step up ke step down tadi?
Down.
Okay, step down. So with step down, current primary or current secondary yang besar?
Primary.
Benda balik Maminah ni. Cakap memang terlalu lupa lah rumus tadi kan. Saya cakap pun kamu pun lalu sebelah, kamu pun tak buat tak nampak je rumus kan. Kalau step down, dia terbalik. Okay, current dengan voltage is terbalik. Kalau step down means the secondary current should be higher or lower than the primary?
Higher.
Higher, right? So is it shown here higher? Primary current up here, secondary current down here.
The value higher.
The value is higher or not?
Yes.
It's higher, right? Okay, so the theory is proven. Okay, the theory is proven that you can see here that the amount, but okay, and then again to do something, okay, so step up tadi, so voltage is, kita pakai step down kan, step down, so voltage is lower in the secondary, betul? Okay, nampak? Betul kan?
Yes.
Okay, so you can see the secondary voltage is lower as we want to step it down to 200. So that's why I wanted to use this because this is very precise tadi. Compared to yang tadi tu, ini dia kita letak 240, memang dia bagi 240 lah. So your job is to calculate berapa. Okay, berapa windings tu. N1 berapa, N2 berapa, boleh?
Okay, sir.
Boleh? Okay, so the saya pun pakai frequency as 50 because the one that we use here, frequency in Malaysia is 50. Tahu kan? 50 kan? There are other countries in the world that are using 60 And then kalau in the case macam Japan, dia pakai 50 and 60. Dekat utara pakai 60, bawah pakai 50. Ke selatan dia pakai 50. Okay, that one is due to historical reason lah. Okay, but in Malaysia we use standard 50 Hz. Okay, so from these experiments also you can actually do something like in this one contohnya RLC series. Dah belajar kan RLC dalam mana? Dalam circuit theory kah? Ke mana belajar RLC? Circuit theory.
Ada.
Belajar circuit theory kan? Oh, jangan ada yang flashback dia fail circuit theory 1 ke apa? Semua lulus ke circuit theory? Ada yang masih fail ke?
Tak.
Tak ada? Okay, you can actually apply this here, this one, into this. Okay, so you change the, like contoh sini kan, we have this one example contohnya. So you change ini series circuit ni, dia punya resistor berapa, inductor berapa, and capacitance berapa, and then you can also change the the frequency. And then see through calculations and experiments sama ke tak sama. Okay, but that one is something that I want you to explore later lah. Later. As for today, I want the first task tadi apa? Apa first task tadi kita?
Download Matlab.
Ya, betul. Second task?
Tengok video.
Install dulu Matlab. Lepas kamu download, install lah. Jangan kamu download, lepas tu kamu biar dia buruk oleh komputer sudah. You download and you install, okay? You download, okay, second task is you install Matlab. And then third task tadi? Tengok video kan? Ada orang ke tak ada orang dalam kelas ni? Saya cakap sorok-sorok.
Dah,
Ada.
Okay, so yeah. Okay, the third task saya tengok video. Okay, watch that video and how to set up this connection. And then if you look at this one, the experiments tadi our first experiments is actually nak kira ini. Apa the first one? 3.1 experiment 3.1. This one, windings. Okay, resistance of the windings. Yeah, that is actually experiment number 1. It's actually sini, calculate the resistance between these 2 points. Okay, winding 1, winding 2, berapa resistance dia? Macam tu. Okay, so for that to happen, so you tukar. Okay, so saya akan bagi task. Okay, so power tadi untuk task yang satu tadi untuk kira N1 dengan N2. Okay, N1 dengan N2 tu untuk kira. So power ni tukar. This one. This power. Okay, power tu tukar daripada 1000 pergi berapa? Pergi 5000. Sekejap kalau berapa? Daripada 500 lah. Start daripada 500. Boleh tak? 10 steps. Boleh ke tak boleh ni?
Boleh.
Okay, kita buat daripada 500, 1000, 1500. Ke itu sikit sangat? Kan kita buat 1000, 2000 kan? 1000, 2000, 3000, 4000, 5000. Boleh? Boleh
Boleh.
Okay, so we start with 1000 until 5000. And then yang ni parameters ni biar. Tak kacau. Parameters 1 is 400. Parameters 2 is 200. Please make sure in your experiments too, whatever setting that you use, screenshot ini, dia punya ni. Dia punya setting ni. Oh, what happened? Where's my Matlab? Okay, screenshot dia punya setting tu. So that I will know that you are using the same settings. Boleh
On.
Okay. So this one 400 is input, 240 as output. That is first experiments. Kira N1 dengan N2. Okay, kira N1 dengan N2. The second experiments tadi kita tukar. Okay, you tukar this one. Okay, you tukar. For this one, for second experiments tu kita tukar from step up ke step down. Boleh? Kita letak 100, 200 sampai 500. Boleh?
Boleh.
Okay. So sama macam atas tadi 1000 to 5000 untuk kira N tu. And then second one is this one, tukar ini saja. Output ni tak payah tukar. Okay, output tak payah tukar. So kita tengok sini 100 volts, 200 volts, 300 volts, 400 volts and then sampai 500 volts lah 5 kali. And then nominal power tu letak 5000 for the second experiment. Okay? Okay. So those are 2 experiments. Okay, 2 experiments that I want you to do for this one. So saya nak tengok juga siapa dia punya circuit paling cantik lah. Okay. Nak tengok siapa dia punya Simulink paling kemas.
Ada extra markah kata.
Tak boleh ke?
Ada extra markah ke kalau sama.
Ada. Saya tengok skill pakai Simulink ni. Okay, so as you can see, the other thing that you should notice from this, apa dia? What is similar between these two? Voltage dengan current. Input primary and secondary. Ini nampak kan dia punya graph ni, nampak kan? Okay, so what are the differences? Bukan differences. What's the thing that is the same?
AC.
Apa dia?
AC.
Lo yang buruk lama mati. Memanglah AC. Janganlah lo yang buruk sekarang. This is memanglah kita pakai AC. Okay? This is macam tadi this is a linear transformer, means kita tak kira dia punya losses. Kita anggap it's ideal. Okay? There is no dia punya core losses dalam tu, there is no losses due to heat and everything. Okay? So kita pakai rumus yang ideal tadi, yang rumus yang VP over Vs over VP sama dengan NS over NP kan. Okay, we use that formula, and then IS over IP equal to IP over NP over NS tu kan. Kita pakai that formula. That's the meaning of a ideal transformer. But looking at these results, what can you notice from this? Apa yang sama? Walaupun value dia tak sama, walaupun value dia dah tukar, dia dah step down voltage, and then the current dia pun tukar value, tapi what stays the same?
Power.
Can anybody?
Power.
You cannot see power from here. No? Unless you do calculations. Okay, unless you do a proper calculations, you cannot see the power from this. Betul? This is something that you can see.
Yes.
Time, sir?
Siapa sebut face tadi?
Zul.
Zul.
Siapa sebut face tadi?
Zul.
Boleh bagi makan bonus lah.
Wow.
Nice.
Boleh nanti letak dengan grup kamu. Saya cakap face dah dalam report kan. Bagi makan bonus sikit. Okay, so as you can see, this one has the same phase. Okay, input and output are at the same phase. Why? Okay, dah lah dia pergi daripada primary ke secondary. Dia tak ada delay kah? By looking at it, there's no delay, right? Yeah, they are at the same phase. So, graph kamu nanti, yalah. Okay, why is it on the same phase? Why is there no delay? Any answer? Any answer?
Ideal transformer.
No. Tak ada markah bonus untuk kamu. Salah tu. Not because ideal transformer. Far from it. Ada siapa nak try? I'm doing this today because banyak kamu tak install lagi Matlab so that's why baik kita belajar je lah sebelum buat experiments. Next time mesti dah install. Yes, for now saya tanya dulu. Kenapa dia the same phase? Okay? Nak tengok ni tak? Nak tengok ni why the same phase? Nak besar lagi besar. Boom.
Resistive load kan.
Badai. Sama tak? Kita bagi makan lebih. Makan bonus lah. Okay, as you can see here, walaupun dia tak load here, the one connecting here is just a resistive sahaja. Okay, pure resistive branch here. Okay, there is no inductance, there is no capacitance that can induce delay. Okay, that can shift it forward or backwards. Okay, so you can buat eksperimen sendiri. Okay, buat eksperimen sendiri. Saya lupa berapa Henry, mini Henry. Saya lupa inductance berapa bagus. Okay, like this one kah contoh. And see how input and output shift phase. Okay, see, that's why Okay, you can also do open circuit. Okay, experiment. So, or you can do all. We change the value here. Ikut suka kamu. To see. This is a good opportunity lah. Good opportunity that you can use to actually see in real life how this one reacts, how it behaves under different condition. Okay. So as for tadi saya buat ni saja. Saya buat R saja. Okay. So that's why, because this is a pure resistive punya circuit. That's why there is no delay or phase shift. Okay, good untuk siapa yang answer. It means that you paid attention lah somewhere during the circuit theory tu. Okay, the others learn from siapa sahaja yang menjawab tadi tu lah. Okay, so this is my circuit that I built from the video yang tadi YouTube punya ni tadi guide tadi. You are free to do experiments on it. Okay, what you need to present ataupun ni tadi hantar tadi adalah yang 2 eksperimen saya cakap tadi kan. Any other things you want to do with this circuit, suka hati kamu, up to you. Okay, and then find a way to macam tadi resist yang second experiment tadi, because we want to find the ni kan, dia punya windings punya resistance kan. Okay, the winding resistance. So find a way macam mana nak kira resistance between these two. Boleh? Boleh?
Boleh, sir.
Betul korang ni I will actually nanti saya simplify lah arahan tu kalau boleh kalau saya rajin. Kalau saya tak rajin, macam mana? So as for the ni tadi, this branch tadi, right now we stay ni saja, we stay resistive. So in later experiments, if we have time, we will revisit the circuit. Nanti kita tengok macam mana the different type of will will influence the value here. So yeah, that's it. That's your experiment. Siapa sini pernah pakai Simulink? Ada pernah pakai Simulink? Kita pernah pakai?
Tak pernah sir.
Ui, tak pernah pakai ya?
Tak pernah sir.
Okay, so this Simulink Okay, Simulink is actually just Matlab saja sebenarnya. It's Matlab coding. Okay, it's Matlab coding for siapa yang malas nak buat code. Siapa saja yang malas ataupun tak berapa rajin nak belajar coding macam saya. Okay, because all this block, contohnya kan, like this one, contoh display saja. Okay, you can actually tengok code dia. Okay, dia ada code dia. Matlab code dia ada. Macam mana nak buat Matlab code dia? Properties kah? Saya pun tak lupa lah. Okay. Dia adalah Matlab codes yang simplified into blocks. Okay. It's like, okay, this is the library here. This is the library provided here, where you can do what Matlabs can do normally, like macam math operation. Okay, math operation ada tambah tolak sini ya. This one. Okay, tambah. Okay, so this block kamu boleh letak tambah tolak. Boleh tukar jadi tambah ataupun tambah tolak tambah, contohnya. Something like that. Apply. So jadi macam ni. Okay. So you put a constant, tambah, tolak. You can actually do the same thing here, right? 1 tambah 1 kan? Answer 2. Okay, this actually the same code, tapi you don't need to do coding. Okay, there's no need for you to do coding. Okay, you do block, main block. Siapa suka main Roblox? Main apa lagi? Minecraft ke apa semua?
Saya.
Yeah. So this is something similar. Instead of doing coding, yeah, you just susun blocks. See, this whole thing, you ambil ni, choose everything here. Okay, choose everything here, except for ini kah contohnya. Except for this one, yeah. You can just right click. Alamak, hilang lah pula. Okay, jap, saya ambil balik semua. Okay, so saya tak nak ini, saya tak nak ini tak payah. Ini pun tak payah. Okay, so this whole thing you can just right click on it. Manalah ataupun nak right click ni, dia tak keluar. Okay, and then you create a subsystem. It just become a simple block. See, a new block that contains everything we made just now. See, that is Simulink. That is Simulink. Okay, there's sebenarnya a bunch of codes made into blocks so that it can help people that doesn't really like programming macam saya contohnya. Okay, I like to do experiments with Matlab, but I don't like to do coding. So I like to use Simulink like this one. Okay, so this is a good opportunity for you to learn. Okay, then where you found Simulink is here in the, if you open Matlab later on, sini ada, this is yang original lah. Okay, kalau kamu buka Matlab dia ada kat sini kan, this one here. Okay, you press Simulink and then you just open a blank model. Okay, you open a blank model here, it will give you a blank model lah, a blank model of this one. Okay, where you find the library, you click here. Okay, it will take for first time launching it will take some time. Okay, but everything you need is here. Okay, so yang paling simple sekali kita ada maths lah, maths operation. But for those yang ini power tadi, kalau kamu tak tahu mana nak cari, okay, just search here. Okay, this is a good opportunity lah. This is a good opportunity for you to not just do experiments, but also learn how to use Simulink. This will help you tremendously during your FYP later on. Because kalau saya punya FYP memang pakai Simulink. Okay? Because my project is more about macam buat kereta kan, control system for a car. It just doesn't really macam apa nama viable for me to actually buy a car and do experiments on the actual car. It's not cost effective. So I do my experiments here using Simulink. Okay, so hopefully that helps in explaining a bit on what Simulink is. So this is a chance for you to actually learn how to use Simulink. Faham tak? Boleh tak? Hilang dah semua. Hello?
Inshallah.
Okay, this is a good opportunity for you to learn Simulink. Then I hope you use this opportunity lah, because this one is not the one that you are going to use just this one time. You will use it again later, especially during your FYP later. Okay, so for tomorrow, saya tak payah buat kelas. I will leave you with these two experiments, boleh? Boleh ya? Okay. So you will have 1 week to learn basics on Simulink, macam mana nak pakai Simulink. And then do these experiments using, there's a lot of guidance on YouTube that you can find. Yeah, there's a lot of guidance there. Please use the technology to your advantage lah. Okay, boleh ya? Okay, so yeah. So for those yang rasa macam first time tadi, it's actually not that simple lah. Okay, it's not really that simple to do. Simulink is what I explained to you tadi is the simplified version of it. Okay, but for you to use Simulink more effectively, there's a lot of other things involved that there's no need for me to explain here lah. Okay, but like macam ni, dia punya solver, different ODE, okay, different ODE will give you different results, okay, different kind of output. See, there's a lot. Okay, a lot of stuff that can be done in minutes. So for those yang baru first time buat buat Simulink, is it interesting? Is it easier than coding? Should be easier, right? Kan? Nampak lebih mudah and more fun than looking at codes kan, buat code. Okay, coding, programming itu ini unless you really love programming lah. Unless you really love programming, then yeah, the Matlab programming is for you. Yeah. So I think I will leave the class here. Okay, for your experiments, for you to do your experiments. So if you cannot do on your own, so please do discussions with your group members. The requirement for the reports is the same. Okay, macam yang Dr. Hazul bagi tahu tu sama, semua sama. And yeah, don't forget to screenshot lah macam ini tadi yang the important stuff on ini, contohnya your setting of your transformer, and then the setting of your ini tadi, okay, voltage source. Yeah. And I think that's it. I will leave you there. Leave you with this. Okay, so I'll see you guys again next week. Boleh?
Boleh, sir.
With everybody already installed. Already installed Matlab lah. Okay? Okay. So all the best.
Sir,
Attendance je tahu. Kau baru masuk apa ni?
sir, I have a question, sir.
You have question, okay? Yeah.
When is the due for the report?
Alah, buat dulu. This one. Dia minggu depan.
Apa tak, sir?
Buat dulu this one. Okay, we do this first. Due minggu depan.
Minggu depan, sir.
Yeah. End of next week.
Sunday kah ataupun Jumaat, sir?
Benda hari apa? Hari Jumaat je lah.
Okay, sir.
Okay, hari Jumaat I will enable the submission link on Elip lah later on. Boleh?
Sir akan share kah 3 PDF tadi, sir?
Ya, boleh. Saya akan share. But it's just that siapa punya yang echo ni? Okay, so it's just that the procedure of the experiments will be different. Betul? Because you are doing totally different experiment from that one. So yeah, I want to see you come up with your own procedure lah. You come up with your own procedure based on that video, Okay, based on that video that I will share later on Elip lah. Okay, so dalam report kan kena buat procedure kan. Okay, so pandai-pandai lah kamu. Saya nak tengok instead of tukar ayatnya, how do you come up with your own procedure? Menarik tu, because that one will be a good training for you for your FYP later, because itu part methodology methodology, how you present, how you present to people, how you did it. Okay, so mana lagi tadi share apa nama attendance lupa pula. Okay, jap saya buka attendance jap. QR attendance. Okay. Jap. Mana pergi datang ni?
Nak reconfirm tomorrow we don't have class, right?
Tak payah buat eksperimen.
You said you will guide us.
Pergi download Matlab, install Matlab, belajar buat Simulink.
Sendiri lah.
Apa?
We're on our own lah.
Ya, lah kata tadi ada group.
Yalah, group member lah, based on group member.
Discuss lah dengan group, buatlah session dengan group sendiri. Ya, macam mana kita nak buat ni? Siapa buat ni? Siapa buat eksperimen? Siapa buat ni design circuit semua? How ni? I ask you to do this because the guide is on Matlab. Ada dekat video YouTube tadi. You just need to follow that. But yalah, kita tukar dia punya value tu to get the data that we want lah. Okay?
Okay, sir.
Yeah. Okay, so tomorrow there will be no class. I will leave it to you guys to do it on your own lah. In group lah, especially submission nanti pun will be in groups in groups. So just one representative from the group to submit on Elip. Okay? Penurus Syamimi baru ni. Baru check in ni.
Manual attendance, sir.
Apa dia?
Manual
What?
attendance.
Manual tadi. Ada manual. Siapa tadi nak ini semua dah kah? Dah saya buat manual attendance now.
Dah.
Kira dah lah. Okay, so how to do this? Coba buat sini buat sini. Okay. Sini. Person. Apa tadi?
Abdullah Cafan.
Ya, sir. Nombor 5, sir.
Okay. So saya ni stop recording sekejap. Stop. Okay.